In this segment, we will explore parallel arrays. We already know that an array is a memory location that can hold multiple values. So they are multiple scalar variables connected together to hold information. In this example here, we see that the array can hold maybe a group of strings. And over here, we see an example where the array can hold a group of integers. Parallel arrays are used to hold a group of related information. So for instance, in this example, we have car owners where we're capturing the car's owner, the car type, the car color, mileage, and the number of passengers that car can actually accommodate. So we call these parallel arrays because in parallel, for instance, all of the elements in the subscript 1 relate to the same information. So Peggy has a Honda that's gray with 44,000 miles and can carry 5 passengers. So parallel arrays. The first thing we note about parallel arrays is that when we declare them, they must be of the same size. So in class we talked about creating a constant, and we'll call this constant max car. And then when we declare these arrays, owner, car type, color, mileage, passenger, we will declare them of the same size by using that constant. Remember, a constant must be used here and not a regular integer to declare this. Now, one thing about any arrays, much less parallel arrays, is that we always want to declare them of a maximum size, but we can find out that during the execution of our program that we may not use all the elements of the array. So max size is the maximum number of values we'll have in that array. For this sake, max car could be made 20 here to more accurately depict the illustration. I just have 20, but max is 25. But you see even here with this that only 15 elements are populated in this array or in these arrays. So max arrays, though it might be 25, and again, I don't have them all depicted here. This would go down to 24, subscript 24. Although we might have that many elements, we may not use all of those elements. So before, when we looked at our for loops were always going to max elements. Well, it turns out that these arrays might be what we call partially filled, which means even though we have 25 elements, we may only use 15 of them. If we have that, then what we want to do is keep a counter to see how many elements are in use or how many cars we actually have. And we're going to use a variable called numCars for that. So numCars is declared as an integer, and it's going to tell us exactly how many cars we have. When this program first starts out, numCars is going to be 0 because we don't have any cars. The idea is to fill all of these arrays in parallel with the information from each owner or each car. So when I look at the information in the file, I have the name of the owner, the car type, the color, the mileage, and the number of passengers the car can have. And I'll have that information consecutively for each element. I'll have that information consecutively for each car that we have or each owner that we have. So let's take a look at some actual implementation of parallel arrays. So again, I have declared here in the main 5 arrays in parallel, and I'm calling this size now, but we'll stick to names like max car or max student or max employee or whatever we have. Size is a very generic name. We're just using that for this example here. So I declare all of my arrays using that constant that's global, by the way. So anytime I want to use it somewhere else, I don't have to pass it. And I also have this numCars. Again, I set numCars to 0 because I have no cars at this point. Now, at this point, I want to call on a function to actually fill the arrays with information. And then you see right after it, I'm going to call on a function to print out all of the information. So numCars here is 0 going in. And notice to pass an array in the argument list, I have no distinction between passing an array and passing a scalar variable. They are all passed the same. I just give the names of them. But if we look up here at the prototype, I see that when I'm declaring an array as a parameter, I must include empty brackets there to let the computer know that this is an array and not a regular scalar variable. So I have car type, owners, colors, all being passed as arrays with that little empty brace. So this is different from the declaration in that I don't give a dimension or size of this thing. The number of elements is determined by the declaration. When we pass it to a function, it will be that same size. One thing you'll notice here that in get cars, I'm sending in num cars as 0, but of course, as I fill this array, I'm going to be changing num cars to represent exactly how many cars I have. So when I'm here at subscript 4, I'm actually going to have 5 cars, 0 through 4. So that value is going to change inside of my function. Because that value is going to change inside of my function, I send it by reference. So it goes down as 0, and when we come back up, it will have the actual number of cars I have. So if that happens to be 15, num cars will then be 15. Why is that significant? Because if we peek ahead, for all of our functions now, the for loop is going to operate from 0 to num cars. So if I have 17 cars, we're going to go from 0 to 16. This is not the same as going from 0 to max cars. Again, if the array is partially full, I won't have any values after the 15th car, so to speak. So all of my for loops now are going to go from 0 to num cars. So you may ask yourself, well, why do you have just the reference in front of the cars that's going to change, but all the arrays are also going to change? Why don't they have references in front of them? It turns out that arrays are passed by reference by default. You know, we talked about by reference really means sending the address of the variable down. Well, what happens is with arrays, the addresses are always sent down to where the first element starts. And we talked about the off by one and going to the apartment buildings. Well, if I send you the address of the apartment building, then you'll start there and work your way down to the apartment that you want. Again, we're talking about elements here. So by passing the name, we're actually passing the arrays by reference by default. So anything that's changed here is automatically changed when we come back from that function. So again, two things to note. In the call statement, we do not put any indication that it's an array, no subscript notation. In the function prototype and the function header, we indicate it's an array by an empty bracket right here. So let's look down at the actual function here. Here's the function get cars. The same way I pass it, the same order must be the order that in which I catch it. Okay, so the last thing that's being passed is the num cars, and that's the last thing being caught. Please also note in the main I called it num cars, and in the function I'm calling it n cars. I can call it something differently. And then this notation should look familiar, but let's talk about it. First, I'm creating a file variable here, and notice I am opening and closing the file within this function. Why? Because I only need to open the function to get all the data out of it. Once I get the data out, the data is now in those arrays, and I can simply use the arrays. So I now have while not in file end of file, and n cars is less than size. What does that mean? Well, if I declare my array of size 20 or 25 or whatever the case might be, and I have 50 cars in there, I'm going to have an out of bounds error because I'm going to go past the end of the arrays. So what I want to do is as soon as I get to the maximum number of cars that fills that size, I want to stop. So I'm going to stop the process whether I hit the end of file or I run out of spaces to put the cars in my array. And now I have the get line in file to read in the name, that's a string, the car type, which is a string, and I'm reading in the mileage here, and then I have an ignore because the mileage is an integer. I'm going from an integer to a string. I have an ignore there. And then I read in the color and the passengers, and I have another ignore anticipating when I loop back around, I'm going to be going from the passengers, which is an integer, to the owner, which is a string. But notice here, n cars came in at 0, So when I read the first information in, it's going into owner sub-0, car type sub-0. The next iteration of the loop, I change num cars to 1. And when I loop back around, the next information is going into car sub-1 and car type sub-1. So each time through, I'm going to be filling all the information or a particular owner. So the second time through, when num cars is 1, I'm going to be filling up the second one. When num cars is 2, I'll be filling up the third one, and I'll keep doing that over and over again until I run out of space or I run out of information to put in the array. Please also note that once I put one person in there and add 1 to cars, then cars is 1, which means I have one person. So num cars is also telling me how many people I have, in addition to telling me where the next person should go. When this loop is done, although I'm putting all the information in sub 14, when I'm done, I'm going to increment it to 15 to say that I have 15 cars in here. And that's exactly what I have. So I'm going from 0 to 14, and my number of cars is 15. That means that every time again through these for loops, I'm going from 0 to less than 15. I'm going to 0 to 14 to process this information for the cars. So once I'm done with this loop, the arrays are populated. The count indicates how many elements I have. We close the file, and then we come back up to the main program. The next thing I'm doing here is printing out the car information. When I print out the car information, I am doing a lot here. So notice the first thing I'm doing here is I have this keyword here left, which means that everything that's printed out from here on out will be left justified. So I only need to do that once, and then everything is left justified. If I want to go center or right, I do it once, and then everything after that is printed center or left justified. So I'm printing out a header with the owner, car type, color, and I'm also printing out a little dash for the header to give it a nice, neat column header. And then I'm getting into a for loop where I'm going from 0 to num cars, and I'm setting the width to 15. We talked about the width. The width says print my name in the space of 15. So set width goes for whatever comes after it. So it's like you're setting the place and then dropping something in that place. So we're going to set up 15 spaces and put owner in those 15 places. So if owner is Tim, we're going to print TIM, and then we have 12 spaces until we see the next thing, the car type. What that's going to do is line things up nice and neatly. So we print out the car type, the color, and notice that the spaces here are exactly the spaces that I use here. So when I print this out, it will be in nice, neat columns. Let's take a look at the code in Visual Studio. So here again, I have the information that I just showed you in the handout. And in addition to that, inside of my for loop, I have this little nice, neat thing going on. What is this? Well, count is going to go 0, 1, 2, 3, 4, 5, 6, all the way up to num cars, which is 15, right? But when count plus 1 mod 3 is equal to 0, I am actually going to print out a line separator to separate my output. Let's see how that looks. So here I see I have a line separator between everything. I have 15 spaces for the names, and everything else is printed out in 8 spaces. So that gives me nice, neat columns like this. When K is 2, 2 plus 1 is 3, 3 mod 3 gives me 0. After 2, I print out a line space. So I print 0, 1, 2, a line space. 3, 4, 5, a line space. And I'll keep doing that to make a nice, neat separator there. So let's recap. First of all, parallel arrays must be declared of the same length. And then we looked at how to pass these parallel arrays to 2 functions. Notice again, when we pass these items, we do not indicate any notation for arrays. But when we catch them or put them in the parameter list, we do indicate that they are arrays by putting the open and closed brackets. For the num cars that scale a variable, we pass that by reference in order for it to be sent back or to be used in the main program after it's updated. But for the arrays, they are by default passed by reference, so we do not need the reference operator. We looked at num cars and we set it to 0, and then we realize every time we read in a new car, we're going to up it by 1 to say that we have a new car, but also to indicate where the next information is going. So when this goes from 0 to 1, the next owner will be read into car sub 1. We also opened and closed the file within this because afterwards we don't need to go into that file anymore. We have all of our data inside of the arrays. And lastly, when we printed this out, we kind of used the same format for the headers that we used to print out the details or every line of information. So the same set widths I use here are also the set widths I use there. And then I put this little thing in there to give me a nice line separator so I can easily read the output. Okay, in class we'll talk about how to process parallel arrays, but at least now we know what they are, and we also know how to populate them and print them out.